Okay, hello everybody. So we are now recording, and our today's task is find the inverse of the given function graphically and algebraically. Our given function is defined by the equation y equals square root of x minus 3 minus 2. In this exercise we will see like complex overview of a lot of things, because we will use our knowledge about power functions with radical, or if you want to, fractional exponents. Then you will see how to find the inverse graphically and algebraically, of course. Then during the explanation I will mention also quite important properties of inverse in relation to the given function. And the last thing, or maybe one of the things, I don't know what else will occur in the video, is how to solve simple irrational equation. Basically, irrational equation, as we already know, is any equation where the unknown variable is under the radical. Okay, so let's start. As we already know, our function has its proper parent function, which in this case is defined by the equation y equals square root of x. Okay, so let's sketch this function very quickly. We already know that the function in our xy plane looks like this. It starts at the origin and goes something like this. As we can see, and as we already know, the domain of this function is defined for all the positive real numbers, which can be simply written like this, or if you want to use interval, it's gonna be from 0 to the infinity, and the range of our parent function is also all positive real numbers, which is interval from 0 to the infinity. Okay. So, if you look at our given function, we already know that there will be like two transformations. The first one will shift our function 3 units to the right, and let me just highlight it. So this information is that our function will be really moved or shift 3 units to the right. And the next, or the second transformation, is hidden inside this notation, and it says that our function will be moved or shifted 2 units down. So basically, let's draw our chart, and then we will find the inverse function graphically, but maybe something else will happen. So let's have our xy plane. We know already, and this transformation 3 to the right and 2 units down means that our point, which is placed at the origin and has the coordinates 0, 0, will become the point with coordinates 3 and negative 2. So basically we need here like 1, 2, 3 units. Let me put 4, 5, and we need 1, 2, 3, 4 units down, and let's do it also up and to the left, though this information is not really like needed. So our given function is shifted 3 units to the right and 2 units down. So basically our point, which was in the origin, will be, these were just helpers for me, so will be somewhere here. Now we can sketch the given function. What I find out now, like quite important thing is, and here we will use the knowledge how to solve simple irrational equation. It would be really nice in this situation to find where is the intercept of our function with the x-axis. As we already know, the points which are part of the x-axis have the second coordinate being 0. So we are basically looking for the intercept of our function with x-axis, and we are looking for the coordinate x in cooperation or in connected with the information that y must be 0, which will lead then to the equation. Let me put it here because I will need this space for the graph to draw the inverse. So based on this information, we are now able, it implies that we are supposed to solve the equation 0 equals square root of x minus 3 minus 2. So this is really very simple irrational equation, and as we know already, to solve such an equation is a really clever idea to isolate the radicand. So we do this operation plus 2. So our equation, and I will swap the sides of my equation because I want to have my unknown x on the left side, which is like quite common thing. So my equation after this operation will be like x minus 3 equals 2. Next thing we are supposed to do is to square both sides of the equation, and if we do so, it's gonna be like x take away 3 equals 4, which basically means then we do plus 3, so x equals 7. So now we know that our intercept coordinates, our intercept coordinates are 7 and 0. So now we can really finish and have the graph drawn like properly. 1, 2, 3, 4, 5, 6, 7. Oh, clever idea to have it like this, but let me move this a little bit to the right so that I can extend x-axis. So basically here is my number 7, so here would be number 8, 9, 10, and so on. So the graph of our function given is 1, 2, 3, 4, 5, 6, 7. Here is my intercept, and I can now draw my function, something like this. Okay, so this is the given function. F of x equals square root of x take away 3 minus 2. Now we want to find the inverse graphically. Basically, how do we do and how do we find the inverse of our function graphically? As far as we know, the inverse is symmetric with respect to the line whose equation is y equals x. Basically, it would mean that our point, which coordinates, and let me write it here, which coordinates are 3 and negative 2, will become the point with coordinates. You think about it? Yes, it's gonna be coordinates negative 2, which is here, and positive 3. So here is my point. Basically, if I would draw everything properly, it should be clear that if you connect this point with the origin, it's kind of straight line, let's say, and perpendicular to y equals x, and the distance of this point from intercept of blue and red line is the same. Okay, now what else is important? The next thing quite important would be to find another point, and that's why it was clever idea. Let me extend also y-axis. It was a really clever idea to find the intercept with the x-axis, because our inverse function will be now intercepting 1, 2, 3, 4, 5, 6, 7, 8, will be intercepting y-axis at the point with the coordinates 1, 2, 3, 4, 5, 6, 7 with the coordinates, yes, you were right, 0 and 7. So this point's coordinates are 7 and 0, and this point coordinates are -2 and 3. Now it's easy just to, oh, sorry, this is really hard to draw, sketch, okay, but you can imagine that this is something which is symmetric with our given function with respect to the line defined by the equation y equals x. Basically, if everything would be drawn really properly, you would see that this point, that this point is really symmetric, and this line is again perpendicular, okay, with the respect of the symmetry with the line defined by the equation y equals x. So our job is done here. This is something how to find the inverse graphically. Let's mention another quite important thing. Okay, as we can see, our given function, which is this one, the domain of this function is 3 to the infinity, and the range of this function is -2 to the infinity. And as we said during our lessons, if we find the inverse function, which is in this case, and let me just redraw it so that it's in orange and we can really use the colors to differentiate the inverse and the given function, the original function. Now our inverse function, we still don't know the equation of our inverse function, which we will find later on when we will be finding inverse algebraically. So I'll leave this space empty. Here it should be some expression. We will find out later, as I said. But we can say that the domain of our inverse function should be now what? The range of our given function, or the original function. And as we can see, we did the graphic job like really properly, because from the graph you can see that the domain of our inverse function is really from -2 to the infinity, and the same applies for the range of our inverse function, which is from 3 to the infinity, which is again the domain of our original function. So this is really like quite important information to remember, or fact to remember, that the domain and the range of original function swap, and they become the domain and the range of the inverse function. Okay, basically this is everything. We have done our job when we wanted to find the inverse of the given function graphically. Now let's have a look and let's find the inverse algebraically. For this purpose I will delete this part of the screen so that we are really fine and have enough space to do so. Okay, so we said that if we want to find the inverse algebraically, it basically means that our inverse, first step is to switch or swap x and y. So we know that our equation for the inverse should look like x equals square root of y take away 3 minus 2. Now, as this is called really like inverse function, the only thing we do here, we apply inverse operations. We have like plus take away 2, so the inverse operation is plus 2. So we will have x plus 2 equals square root of y take away 3. Now, what is the inverse? If we want to get y, as this is the square root, we will square both sides, and I will swap the left side of the equation with the right side because I want to have y on the left side. So in this case it will be like y take away 3 equals x plus 2 squared. Okay, now what else do we want to do? Yeah, we want to have y like alone on the left side, so the next operation is plus 3, which will lead us to our equation x plus 2 squared plus 3. Okay, so this is our inverse function or the equation. To be really like with the proper notation, I will rewrite this. So our inverse function is defined as y equals x plus 2 squared plus 3. We are done here, but I want to show you that we really did our job when we did the thing graphically properly. And let's sketch the graph of our inverse function, and we will compare with this orange line. As we already know, this is quadratic equation, and as we already know, there are two transformations applied. So quadratic equation apparent function is parabola which goes or passes through the origin, and we know that the transformation is done 2 units to the left and 3 units up, so our vertex of our parabola of the parent function will be moved to -2 and +3. 1, 2, 3. As I already know what I want to get, I will make this line a little bit longer. 3, 4, 5, 6, 7, 8. You know already why. So here is my vertex, and let me just use the orange one so that we will see that the result is really the same like above. So this is vertex of my parabola, and here is really something important to mention, and I will explain how to find out even if you are not doing or finding the inverse graphically. As we know, the graph of this function is parabola, so we would be supposed to draw the chart like this. Again, here the question is where is the intercept with the y-axis? But as we already know, the intercept with y-axis has the first coordinate 0. We can simply calculate and make sure that our point 0, 7 was calculated before correctly, which means y equals 0 plus 2 squared, which is 4 plus 3, which is 7. So we really can calculate it easily and quickly, and we see that our intercept is really with the coordinates 0 and 7. 1, 2, 3, 4, 5, 6, 7, and this is our point. So my function passes through this point like really. Now, the thing is that we know already that this kind of function is not invertible, and we have to strict the domain because we cannot do inverse function of quadratic function. But how can we find out which part of the parabola is our graph? So basically we already know that this part of the parabola doesn't belong to our inverse function, so I will simply delete it for now. And how can we find that this is the solution? But look, it's really very simple, because as you already know, this is our given function, and as there is the square root of x take away 3, and we know that the square root function is defined only if the expression under the square root is greater than or equal to 0, then it must be true that x minus 3 must be greater or equal to 0. Okay, now I know. Okay, which is the domain of our function. So it means x is greater or equal to 0 to 3, which means if we take in mind that the domain of our function is now the range of our inverse function, okay, it means that our range is really from 3 to the infinity, okay, which is okay for our function. And now we should find out where the domain of our inverse function is, which is really like simple, and it would mean that we fill in our inverse function with the number 3 and we solve quadratic equation 3 equals x plus 2 squared plus 3, okay, which means these 3 will cancel each other, and it would lead to the equation that x must be greater or equal to a negative 2. So our domain is from negative 2 to the infinity. Okay, so I think that's all for now, and I think all the information were given. So we went through the power functions with rational or if you want to fractional exponents. We used this information when we were drawing the original function or given function. Okay, then I showed you how to find graphically the inverse function with the knowledge that the given function and inverse function are symmetric with respect to the line defined by the equation y equals x, and with knowing that the domain is that the domain of the original function is becoming the range of the inverse and vice versa, with the informational knowledge that if we have the point of given function and we want this point to be like point of the inverse, then we simply swap or switch x and y coordinate of the point, and we get the point. And then we found algebraically the inverse using also the properties, and yeah, that's it. Thanks for watching. See you during our next video. Bye.